Okay, so this is indeed a presentation that Sergej normally does. Sergej is the Thermo leader. The other two active members in the Thermo group are myself and Klaus, who is not here today but is online. So we have a meeting every week, and Michel is also part of that meeting. So this is a presentation authored by the four of us. The scope of the charter is the thermodynamic property specification version 1.0, which has been deprecated a few years back, and the thermodynamic and physical property specifications version 1.1, which is very much active. We're still extending that. The chemical reactions interface specification version 1.1. It says here under development, but really we've released it for request of comments last year after a number of years. And what we're waiting for is the general manager specification, which this presentation is mostly about. We have released last year the custom data interface specification, and I hope we get to see its first interaction or its first implementation today. I'm not sure what is in their presentation, but so I'm not going to give any spoilers there. And there is a draft for a compound server interface specification, but that draft has been on hold for quite some years, pending renewed business interest of the company that actually launched that draft. So we keep track also of all related files, tools, software, and procedures. The key responsibilities, the wording of this has changed somewhat since the last couple of years, but if you want to have a look at the actual charter, it is online on the CO-LaN website. Our key responsibilities are to maintain and manage the active specifications with revisions to improve the design, performance, speed, and robustness based on user input. We provide errata and clarifications document and integrate the errata and clarifications into the current specification. We assess and prioritize on expansions of the thermodynamic interface specifications, and we help member organizations to develop implementations of thermodynamic interfaces, where we provide advice on migrating from the deprecated 1.0 interface to the active 1.1 or 1.2 interface specification version. We provide advice on new implementations, and we analyze interoperability issues between PMEs and PMCs should they occur. A new task on our list is to define the compliancy test for thermodynamic interface specifications, it says here, but that should really say define the compliancy test for testing thermodynamic software components. We start with property packages there. So our membership is Sergej, myself, and Klaus and Michel. This was already mentioned on the title slide. Björn has been actively taking part in the SIG in the last years, and he provides feedbacks on documents, but he is not actively taking part in the meetings. Same goes for Mark. He is very actively replying on requests that we send out for comments, and his input is very helpful there, as usual, but he's also not currently actively taking part in the meetings. And the same goes for Richard Spansky. I think he's also on the call today. His input is, of course, very valuable and welcome as well, and not actively taking part in the meetings. We had Aspentech and Honeywell representatives on the SIG in the last years. The status of that is unclear, and we're investigating as we speak. We're still waiting for feedback from both companies on it. What we have done in the last year was we presented in 2021 that we have finalized the draft of the chemical reaction interface specification minus the part that deals with the common manager interface. So we have launched it for a request for comments, and we've got back extensive review documents from Linda, for which we are very thankful. Not only that we spent many hours discussing them, but it also actually resulted in a bunch of clarifications in the document, and in 1 or 2 places we actually changed the interface specification design based upon your feedback. So thank you very much.
Apologies.
Sorry?
Apologies for making you so much
work. No, it's good. This is an interoperability standard that should not come from one specific group. The specification document for the manager common interface we have started to draft inside the Thermo group. We have formulated all the requirements and interface design. We have formulated 8 use cases and 15 requirements, and we're currently in the process of finalizing the draft with the notation there that it is a draft. It is not up to the Thermosig to put this particular document forward. So why are we making a common manager interface specification again? It is a generic alternative that can represent a property package manager, a reaction package manager, and perhaps a unit operation manager, which we do not have currently. Reaction package manager is of course in the reaction package design. The reason we do not want to do this in separate interfaces is because there's a large overlap in the functionality of all these managers, of course, and the property package manager interface has a number of shortcomings that we want to deal with, that are outlined in the next slides. This is really then a common interface, because a common interface is when it spans at least 2 SIGs. And if you look in the first point, you see that the Thermo SIG and the unit SIG are both involved here. So that means that the document actually belongs in the method and tool SIG. So we're just drafting it and then forwarding it to the method and tool SIG to put it forward for publication. The duplication of similar functionality across all these types of manager is of course something else that makes it a common interface. It is not specific to a property package manager. It is not specific to a reaction package manager. And if we're going to decide that there will be a unit operation manager, which I think we should, then it will be not specific to that either. The functionality in the interface is really the manager part of it, the common part of it. The first application for this particular interface will not be the property package, because we have the version 1.1 and 1.2 IK Thermo property package manager, and we cannot just do away with that because people have implemented against that. So the first application for this interface will be the reaction package manager, as in the chemical reactions interface specification that has been launched. And we are required to publish the common manager interface specification to be able to finish the chemical reaction specification document, because there we actually refer to this document. So that is why the Thermo SIG has decided to pick up this work and move it forward. So let us look at what a manager is. A manager defines a bunch of templates. A manager is really a means to define a whole set of PMCs and register it as one PMC. And the thing that you register is a manager. And in order to define a whole set of PMCs, what we really define is templates for that PMC. So templates, by the very name of the word, are reusable. In the property package manager, we called them packages, but this of course doesn't make sense if it's a common interface, so we choose for the wording templates. The template contains a configuration of a PMC that is to be created by the manager. So the template itself is not a cape open object, only the name of the template is exposed through the manager interface, and upon creation of the PMC, the template is used to initially configure the PMC that you're creating. But at that point, the template configuration, or the configuration contained within the template, and the PMC configuration are decoupled. You can go into the PMC and edit the PMC, or perhaps change parameters, and these changes you make to the PMC configuration are not reflected in changes in the template, which means that it doesn't affect any other documents that rely on that template, and it doesn't affect any future documents that will be created based on that template. Of course, these changes in the configuration that you make to the PMC in your current document that has been created from the template, you should store in your document using persistence. So let's take a look at why the property package manager interface didn't work well for us. First of all, you cannot state the intent of creation. It only supports creation of property packages from a template. And sometimes we don't want to create a property package from a template. A very common scenario is that we did that in the previous session, and really all we want to do is restore the property package that we had saved earlier. And if you only support creation from a template, then during creation, also creation for deeper systems, you have to create you have to specify a template name, which is of course awkward, because the PME needs to suddenly store a template name, which has absolutely zero meaning because it will not be used to actually configure the property package. The package is created with a name that may not exist in the current property package manager on the current system anymore, but at that point we cannot raise an error message yet, because it might be depersisted or it might not be depersisted. So the property package needs to postpone handling any package name errors until it knows for certain that the persistence is not going to be called anymore, which is during initialize. So the workflow of creating a property package from persistence is both awkward for the PME, for the property package manager, and for the property package itself. We can do better than that. The creation of a property package from scratch is also not covered by the property package manager interface. You have to pick a template, which means if you want to create a property package just for use in the current document, you first have to create this configuration in the template, store that template, and then create a template into your current document as a property package. Which is not necessarily useful. So sometimes people avoid that and they drop a completely unrelated property package in the document and reconfigure that to be the new property package in the document. It would be much nicer if the manager interface would actually have functionality to create a package from scratch. So what are these templates then? If we look at the configuration that's stored in a template, for a property package template, it would typically involve a selection of compounds, phases, property models, and associated property data such as temperature dependent correlations, compound constants and whatnot. It is not necessarily possible for a property package template to come up with a good default package that you would use for a new property package creation. I suppose a suitable default for an Aspen properties or a T would be create something that is empty and add the compounds as you go. But if you're a specialized property package manager, for example, for air separation, you can imagine that there is a good default. You would have oxygen, nitrogen, argon and whatnot, specific models, specific phase definitions. So a default may or may not be viable in such a context. So we have also stated that we will use the templates for a reaction, for the reaction package manager. In that case, you would expect the configuration to create a selection of compounds, compound constant, compound data, etc. And of course, reaction stoichiometry, reaction properties, and all the data that goes into that. And perhaps we will go into definition of a unit operation manager. So when is a unit operation manager useful? It is when you have an implementation of a unit operation for which the actual unit operation is highly configurable. Think, for example, of a multi-physics calculator like GPROMS is delivering, or a MATLAB, or even a distillation column where you have different options with different trays, etc. So the configuration for a unit operation manager could really pre-configure a particular type of unit operation to be modeled, including all its hardware, its options, its equations and whatnot. And default template depends really on the type of manager you're looking at. For a distillation column manager, your default could be a simple distillation column. So the design objective for the manager common interface is that during the creation, the PME states the intent of the PMC directly, which means we need to have different ways of creating a PMC. There are three ways, in fact. There's creation from a template, there's creation from persistence, and there's creation where we avoid the use of a template. So it's creation from scratch, which is for use in the current simulation only, not reusable. All the manager types have standalone equivalents. If we say we have a property package manager, we know already we have a standalone property package. This already has existed. If we say we're going to design a unit operation manager, we're not going to do away with the standalone unit operation. This is of course a very common scenario. So one of the textual requirements in the documents is if we define a manager that serves a particular PMC type, then the standalone equivalent to that must also be defined. So the creation from template, the workflow there is very simple. The list of templates is exposed via a function, and then creation takes an element from that list. So the functions on the common manager interface are get template list and then create from template, where the argument to the second function is one of the items that appears in the returned list from the first function. Creation from persistence we have stated in the specification of the common manager interface that any PMC created from a manager must implement persistence, which is distinctly different from the property package manager interface. And this is to overcome the problems with portability that we have seen so far. Currently, we see a lot of property package manager implementations where the PME persists only the name of the package that was used, and then it's up to the end user to make sure that the manager configuration on one computer matches the manager configuration on another computer when you're transferring the document between computers. Or you can transfer a document over time, you can close your document and open it 5 years later, and it is expected that you still have your property package configured in your property package manager. This is not what we want. We want a property package or any PMC for that matter to be persisted in the document that you're using. If you cannot provide that because your underlying implementation doesn't know how to persist itself, you can still provide a minimal implementation that does exactly mimic the situation as before. Just persist the template name and make it a user responsibility to make sure that the template name consistently exists over space and over different computers. But that is not the action we would recommend. We would recommend every PMC that is configurable, which is clearly the case in case of something created by a manager because it exposes multiple configurations. We would advise every PMC that is configurable to properly implement persistence for portability and consistency over time and place. So the deep persistence is no longer the complicated scenario that we sketched on the previous slide. Deep persistence is simply a matter of calling create from persistence on the manager, which will return the deep persisted PMC to the PME. The argument to create from persistence is an object that implements the storage from which it will be deep persisted, which then should match the storage from which it was persisted in the storage that it was persisted with in the first place. So for COM that could be an iPersist stream or an iPersist property bag. For COBI it would be an iPersist reader for deep persistence. So the workflow for creating an object from persistence via a manager is the PME asks the manager to create the object passing the reader that contains the previously persisted data. After that the PME receives a copy of the PMC and talks to the PMC, and the interaction with the PMC should be as if it was created freshly. So you should set a simulation context on it, call initialize on it, make use of the PMC and terminate after you're done. No different from any other PMC. Creating from scratch is optional, and the reason that it's optional is that it might not be possible for any particular manager to provide a decent default to work with. Sometimes it is really complicated to configure a property package or a unit operation to get it into a state in which it's actually working, and you need to do that in an offline application, in which case creation from new is simply not an option. So creation from scratch. Creation from scratch is not something that must be implemented by a manager. It may be implemented by a manager. So a manager is allowed and also expected at the moment you choose create me a new PMC to pop up a model GUI that configures this PMC for first use. And this is important to notice because in Cape Open the only place in which a PMC can pop up a model GUI at this point is iCape Utilities Edit. So we're introducing here a second place in which a model GUI can be shown, and the PME should be prepared for this. You should not call this in a headless environment, for example. This configuration of course can be cancelled, and for a cancellation we would not like to return the PMC that is created and then delete it afterwards. In fact, that message should raise an error, and we have another property on the manager to indicate that the last creation was indeed cancelled by the user, which allows the PME to be a little bit more user-friendly and not show an error message at all, because the user is very well aware that it cancelled the action. So there are three methods on the interface, actually two properties and one method. The first property is, do you support creation from new? The answer to that is yes or no. And then the next method is create new, which doesn't take any arguments and may show up GUI. At that point the user may or may not cancel, and if the user doesn't cancel, the method returns without an exception and it returns the PMC. If something went wrong or if the user cancelled, the method will return an error and no PMC is returned. that the PMC can query the property. Was the last creation cancelled by the user, in which case it can choose not to tell the user what went wrong, otherwise it should probably do so. So those are the methods on the interface. Here's a quick overview of all the supported methods and properties on the interface. All of them have been featured on previous slides. What we're going to do with this particular document is, as mentioned, this is a draft. We are almost done with it. The intent is for its first use to be the chemical reaction interface specification, so we're waiting on this document to be completed and published before we can publish the chemical reactions interface specification. We are not going to use this particular implementation with the property package manager for CAPE-Open 1.1 because there are many implementations out there that already use the iCape Thermo property package manager and they would essentially break. That's not where we want to go. So when do we deprecate this iCape Thermo property package manager interface? Not in CAPE-Open 1.2 either, because that also has been published already with the iCape Thermo property package manager interface. So perhaps in CAPE-Open 2.0 we can finally replace iCape Thermo property package manager by iCape manager. Additional manager types may be defined in CAPE-Open 1.2. The first one that we're expecting to see is the unit operation manager, but this really has to be put forward by the unit operation SIG based upon user feedback, so do please provide feedback. What we're going to do in the next year is we're going to support certification. We need to define the test for all the testing that needs to be done on thermodynamic interfaces, or rather on objects that implement thermodynamic interfaces. We have started the work on property package testing and its documentation. It is very laborious. It will take a lot of time to get that completed, but it is part of our bigger effort to make sure that testing works across the board. And all the other SIGs will have to make a same effort in providing certification support. It is on our agenda. And of course we maintain and manage the existing interface specifications. We finish the draft on the manager common interface proposal, then we hand that document off to the M&T SIG for request for comment, finalizing and publishing. And then perhaps we should make ourselves, or perhaps our community should suggest the unit SIG to initiate a proposal on a unit manager. And then when the manager is published and we can refer to it, we can finally finalize the chemical reactions interface specifications and publish and disseminate it and put the types in the type library and whatnot. So that was the ThermoSig progress for this year. I would like to show a photo of the attendance a little bit more recent next year, but that requires us all to meet face to face. I'm hoping that next year our meeting is face to face.